So for section 6.6, our function operations, the first thing we need to do is remember some of the work we did previously in the first half of this unit about functions. So let's see here. We dealt with functions in section 2.1. Okay, now yes, that's chapter 2. We're on chapter 6, but that's still the same unit. Remember, that was one oddball unit at the beginning of, you look at your note packets, it's right there at the beginning. But in this unit, or in that section, we talked about graphs, and we said, hey, if I've got a graph that looks like this, we were able to determine whether or not it was a function, right? We did that by the vertical line test, okay? And we also saw graphs like this, of course, which was a line, and we said, hey, is it a function or not? We went through and found the domain and the range of these functions. Please remember that the domain stands for the x coordinates. Okay, the range stood for the y coordinates. And on the graph is how we did that. We just kind of looked at the x-axis, what possible values can we have, looked at the y-axis, what possible values could we have. But right now, a bigger thing I want you to remember is function notation. So for example, if I had the equation of the line y equals 3x plus 4, right, because the equation of a line is y equals mx plus b. So if I had that equation, function notation would be written as f of x equals 3x plus 4. Okay, remember that f of x just means y. It's the function notation for y. It says the function where x is the input variable. Okay? And why do they use f? Because, well, f stands for function. We could have named it g of x, or k of x, or h of x, or any letter you wanted to. Okay? It's just a way of naming the function. All right? So today what we're doing then, we're going to be adding, subtracting, multiplying, and dividing these functions. Okay? And so we have just slightly different notation. If we are adding two functions together, we write it this way. So f plus g of x just means take the f of x function plus the g of x function. F minus g of x simply means take the f of x function minus the g of x function. F times g of x is f of x times g of x. And then f divided by g, or f over g of x, is the f of x function divided by the g of x function. Now in this particular case, you have to be careful that your g of x function does not equal 0. Because of course we can't divide by 0, right? So the domain of our resultant function, I call it the resultant function because it's the result of adding, subtracting, multiplying, or dividing. Okay? So the domain of our resultant function will consist of the x values that are in the domains of both f and g. So it's the overlapping of those two domains. Okay? The domain has to be in both functions in order for it to be in the result function. All right, and then it does go on to say that the domain of a quotient, meaning division, needs to make sure that your x values don't make your denominator function. Now here it happens to be the g function, but again, you can name function differently. But making sure the function, the denominator, does not equal 0. All right, so let's go ahead and give this a shot, because right now it's just really notation. You haven't really seen anything yet. So let's take a look at our first example up here for adding and subtracting functions. We have the f of x function is 4x plus 7. We have the g of x function is the square root of x plus x. So if I want to add these, and try to write a little smaller here because I do want to do two separate examples here, adding and subtracting. So if I'm going to add, I have f plus g of x. And again, just looking at the notes, that means that I'm taking the f of x function plus the g of x function. Right? So plug in what those two sets of functions are. So we have 4x plus 7 plus our g of x function is the square root of x plus x. Well, I'm just adding these together. We've done this before. This is adding together polynomials like we did at the beginning of the school year. I want to combine like terms. So I have 4x plus x, which is 5x, plus the square root of x plus 7. So that is my f plus g of x function. Okay? Well, now what I need to do is find the domain. I want to find the domain of this function. So the domain, remember, are the possible x values. Well, we need to look at the original two functions. So looking at the original f of x function, it says 4x plus 7. We got to stop and think to ourselves, what values of x can I plug in? So think positive versus negative. Can I plug in a positive number for x?
Yes.
Yes. Think of a positive number. Say 5. Can I take 4 times 5? Yes. Can I add 7 to that? Yes. How about plugging in negative numbers? Can I do that?
Yeah.
Yeah. Can I take 4 times a negative number? Of course I can. How about fractions? Can I plug in fractions there?
I guess.
Yeah, why not, right? 4 times a fraction, I can do that. Can I plug in 0?
Yeah.
I can't take 4 times 0? Yeah, it's 0. I can do that. And I can take 0 plus 7. I get 7. So there's nothing wrong with plugging in 0 for x in that f of x function. Meaning I can plug anything I want into that equation. Now, think of it another way. I'll go off to the side here for a moment. If I have 4x plus 7, if I have f of x equals 4x plus 7, that is a line, remember, where it crosses the y-axis at 7, and it has a slope of 4. So up 4 over 1 is going to be kind of a steep line, something like this. If I gave you that graph, wouldn't you tell me that my domain is all real numbers, that my domain can be any x value out there? Yes? No? Maybe? Remember doing this? Yeah. Because if we look here, can we start at 0? Can we have an x value of 0? Yes, we can. It's right there. Can we go in the positive direction? Yes, we can, because it goes up this way forever. Can we go in the negative direction? Yes, we can, because it goes this way forever. Remember doing that?
Yeah.
Well, that's all we're doing here, just without the graph. You have to stop and think, okay, what values can I be plugging in for x? And in this case, it's all of them. I can plug anything in for x in my f of x function. Okay? But how about the g of x function? Can I plug anything in there?
No.
Why not?
Because we don't have any other numbers. No.
Okay, you see the square root. What's the problem with the square root? If I plug something in there, where do I have issues?
It should not be.
Has to be a perfect square.
Doesn't have to be. I can take the square root of 5, even though it's not a perfect square.
It has to be positive.
Okay, when I plug them in, it has to be positive, right? Because if I plug in a negative, can I take the square root of a negative number and get a real answer?
No.
No. I can take the square root of negative numbers and get imaginary answers. We did that whole section last semester, right? Finding imaginary numbers. I can do that, but I don't want imaginary numbers. I want real numbers. So therefore, x cannot be negative. Can x be 0? Absolutely. I can take the square root of 0. The square root of 0 is just 0. So there's nothing wrong with x being 0, but x cannot be negative. So therefore, if we're looking at these originals here, the domain of our first one goes from negative infinity to infinity. It's all real numbers. The domain of the second one includes 0, but then goes to infinity. Okay? So what numbers are in both of these domains?
0 to infinity.
Right, 0 to infinity. And so that is the domain of our function we just found. The numbers that are in both domains are then the domain for our resultant function. All right? Questions? There's going to be really two situations where you really need to focus on the domain. One of those is when you have square roots. If you see a square root, you need to focus on what exactly can't the domain be. Otherwise, just like the f of x function, it's going to be all real numbers. It's going to be negative infinity to positive infinity almost every time. Let's try subtraction. F minus g of x is going to equal your f of x function, 4x plus 7, minus, now here you got to be careful, you're subtracting an entire quantity, the square root of x plus x. So you're subtracting, in parentheses, square root of x plus x, and so you have to distribute the negative. Again, you combine like terms. So 4x minus x gives me 3x minus the square root of x plus 7. That is f minus g of x. Okay, what about the domain for that guy? Has anything changed about the domains of f and g?
No.
No. So therefore f minus g will still have that same domain, 0 to infinity. Okay, taking a look at our next example here, we have f of x is 2x squared plus 8, and g of x is x minus 3. Just real quick, let's talk about the domain of these. So the domain of f of x, can x be a positive number? Yeah, I can square a positive number. Can x be a negative number?
Yeah.
Yeah? Can x be 0?
Yes.
Yeah? Can you tell me what shape that graph would be if I graph it? 2x squared plus 8? What shape would that be?
Yeah, parabola.
Parabola. Absolutely. Absolutely it's going to be a parabola. And so if this thing's going to be a parabola, think of x and y axis, and I'm drawing a parabola, even though that's not exactly the parabola we would have there, but what would the domain be of that parabola?
8 to infinity.
Say it again.
8 to infinity.
This parabola here?
So that one would be 0 to infinity.
So I can't have x values in the negative?
I'm thinking range.
I want domain, x values.
So wouldn't that be negative infinity?
Negative infinity to positive infinity, absolutely. So that's the domain here. Otherwise known as all real numbers. There, you can pick anything you want for x and plug it in, it'll work. Okay? How about g of x? First off, what type of shape is that? Sometimes it's just quicker to figure out what type of shape it is, then you know exactly what the domain is. What's the shape of that guy? X minus 3. Do I need to write it this way? Y equals x minus 3? It's a line. Absolutely it's a line. Y equals mx plus b. It's a line. Well, if I give you a picture of a line, what's its domain?
Negative infinity.
Yeah, all real numbers. You can pick anything you want for x. Same thing goes for this equation. Negative infinity to positive infinity. Parabolas, all the parabolas we have ever dealt with, their domain is always all real numbers. Negative infinity to positive infinity. Same thing goes with lines. All lines we have dealt with except vertical lines. Vertical lines are the exception. Okay? But all other lines we have dealt with, their domain is all real numbers. Negative infinity to positive infinity. Nothing has changed. So, looking at this, if I want to add these two functions together, I'm going to take the f of x function plus the g of x function, which means I have 2x squared plus 8 plus x minus 3. So if I combine like terms, what do I get here?
2x squared plus x plus 5.
2x squared plus x plus 5. Excellent. Does it have to be written in that order?
Yeah.
Yes, it does. That is standard form for a trinomial. It has to be written in that order. What is then its domain?
Negative infinity to positive.
Right, because you look at the domains of the individual functions and say, well, what numbers are in both? Well, all the numbers are in both. So there's the domain of our function. Okay, let's try the subtraction. I want f minus g of x. So again, that's going to give me 2x squared plus 8 minus, now be careful, you are subtracting an entire quantity. I'm subtracting x minus 3. And so I need to distribute the negative. So I get 2x squared plus 8 minus x plus 3. And now I can combine like terms. So 2x squared minus x plus 11. That will be my f minus g of x. What's the domain of that function?
Negative infinity to positive infinity.
Yep, still the same. Negative infinity to positive infinity. Questions? So we've tried addition and subtraction. So far, so good. Let's go right below that example and try some multiplying and dividing. So first things first, looking at our two original functions, what is the domain of our f of x function? Negative infinity to positive infinity. Absolutely. It's all real numbers. I can pick anything I want for x. And first off, looking at that equation, looks to me like that's a parabola, right? It's just a parabola shifted down 9. Okay? What about g of x? What's its domain? Same thing. Negative infinity to positive infinity. And what type of shape? If I graph that, what type of shape would I get?
Or a line.
It's one of those two. It's a line. Absolutely. The x isn't squared. Remember, for parabolas, the x has to be squared. Right? But for lines, it's just an x. X to the first power. Okay, so that's a line, and its domain is all real numbers. Well, what if I multiply? So f times g of x. And we will be taking our f, oops, moved on me. We'll be taking our f of x function and multiplying it by the g of x function. That's what that notation means. So the f of x function is x squared minus 9. The g of x function is x plus 3. So how do I multiply those together? FOIL, just like we've always done multiplying two binomials together. X squared times x is x cubed. X squared times 3 is 3x squared. Negative 9 times x is negative 9x. And negative 9 times 3 is negative 27. Are there any like terms I need to combine? Nope. Is it already written in standard form? Yep. So therefore, this is my resultant function, f times g of x. And the domain of this is, again, going to be the overlap of our two original domains. Since both of those are negative infinity to positive infinity, then our domain is also going to be negative infinity to positive infinity. Okay? Questions there? Let's try dividing. dividing. So I want f divided by g of x, which means I literally take the f of x function divided by the g of x function. So the f of x function is x squared minus 9. The g of x function is x plus 3. Looking at that fraction, would I be able to simplify that down? Can I cancel anything out? I cannot cancel just the x's because those are not factors.
Yeah, top is x plus 3x minus 3.
We can factor the top. The top is a difference of perfect squares. So the top is x minus 3 times x plus 3, and the bottom is just x plus 3. So now, yes, we can cancel that entire binomial x plus 3 from the top and bottom. And that tells us that f divided by g of x equals x minus 3. So there's our function. But now the question holds, what is the domain? It's tempting to say it's the same. Every time we have found the domain, and I really didn't point this out as being a big deal, but every time we have found the domain up to now, I've always referred you back to the originals, right? Always look back at the original.
Yeah.
F of x and g of x. And both of those are negative infinity to positive infinity. That's great. Except now, we are dividing by g of x. Okay? And you might look at this final one and say, well, wait a minute, this one is, it's a line, so I can use anything I want. But the problem is in order to get this line, we had to divide by x plus 3. Okay? We can never, ever divide by 0. Therefore, x cannot be negative 3. Because negative 3 is what makes this denominator 0. Agreed?
Yeah.
So that means our domain is going to be exactly what it looked like it should have been. It's going to be all real numbers except negative 3. And so here's how we write that. And we did this before, but you may not remember. I'm going to go from negative infinity to 3, negative 3, parenthesis, because negative 3 is not included in my answer. But I want to have a union with the next set, which goes from negative 3 to positive infinity. Okay? So what does that mean? That means all real numbers, not including negative 3. We now know both situations where our domain has restrictions. Okay? Most of the time, we're going to be dealing with parabolas, we're going to be dealing with lines. Most of the time, our domain will be all real numbers, meaning negative infinity to positive infinity. Okay? But if there is a square root involved, then your domain can no longer include negative numbers. If there is a fraction involved, your domain can no longer include any numbers that make the denominator 0. Okay, those are your two situations you have to watch out for the domain. Let's try this one more time, and we're going to just practice the division because I believe that is the more difficult of the two here. So we want to calculate f divided by g of x. So that's going to be the f of x function divided by the g of x function, which gives us 3x squared minus 11x minus 4 divided by 3x plus 1. So real quick, looking at the f of x function, what type of shape is that going to give me? If I graph that, 3x squared minus 11x minus 4, what's that going to give me? It's going to give me a parabola because the x is squared. So I'm going to have a parabola. So therefore, we know that the domain of that's going to be
Negative infinity plus.
all real numbers, negative infinity to positive infinity. What is the shape of our g of x function?
A line.
A line. Therefore, we know its domain is going to be, again, all real numbers. So when I divide these two, let's keep going here. I need to try to simplify. Well, in order to try to simplify, I have to see if I can factor, because I cannot just start canceling out the 3's or the x's, okay? Those are not factors. I can't do that. So off to the side, I'm going to have to use my x method. Take 3 times negative 4. Negative 11 went down below. Remember, I'm looking for two numbers that multiply to negative 12 but add up to negative 11. Negative 12 and positive 1, good. Now I use those numbers to rewrite that middle term so that I can now factor by grouping. So I factor out a 3x, giving me 3x minus 4. In the second group, I can only factor out a positive 1, leaving me with x minus 4. And so now I can factor out an x minus 4, leaving me with 3x plus 1. All stuff we did at the beginning of the school year. So I have x minus 4 times 3x plus 1 divided by 3x plus 1. Those now can cancel. So f divided by g of x equals x minus 4. The domain of this, will the domain of this be all real numbers?
All except.
All except, well, how are we going to find that? We want to say what makes this denominator 0. And so off to the side we can say, all right, well 3x plus 1 equals 0. So 3x equals negative 1. So x must equal negative 1/3. So x can be anything except negative 1/3. So I write that as negative infinity to negative 1/3, parenthesis, because remember, negative 1/3 is not included, union of negative 1/3 to positive infinity. All right, there's one last thing I want to add, and that is when dealing with square roots. When you see a square root, don't automatically think it's 0 that you can't have. If this was my function, square root of x minus 3, I can plug 0 in there, no problem. There's nothing wrong with having 0 in my domain. Or actually, I'm sorry, I can't plug 0 in there because that gives me negative 3. But I can't plug 1 in, I can't plug 2 in. What's my problem is this entire thing can't be negative. So I want to first find out what values make it 0. X minus 3 equals 0, so x equals 3. Can I take the square root of 0? Yes, I can. The square root of 0 is 0. Okay? But I can't pick any numbers less than 3. Because if I pick 2.5, well then 2.5 minus 3 is negative 0.5. Now I can't take the square root of that. And so the domain of this would be from 3 to infinity. If I had another function, square root of x plus 7, again, I am looking at, well, what makes this 0? So negative 7 makes it 0. I can have the square root of 0. That's fine. But any number less than negative 7, like say negative 8 plus 7 is negative 1. I can't take the square root of negative 1 without using imaginary numbers. And so the domain here starts at negative 7, but then it can be any number larger than that. I can actually use an x value of negative 5. That's fine. Negative 5 plus 7 is 2. I can take the square root of 2. Okay? So watch out for square roots. It's not that you just can't use 0. Okay? It's that you can't take the square root of a negative number.